Hello everyone. Following the last lecture, we're going to do a tutorial video on how to use various finance functions in Excel. In particular, we're going to look at the PV, NPV, and XNPV, how they are used separately and in which situations you might use each ones. So as a quick recap of how we would have done these without financial functions, we've got a payment of $500 in advance for 10 years. And so we're going to look at finding the present value of that. So how we might have done it without using a direct function is find the present value of each of these payments. So we can take the value of the payment, multiply by 1 plus the interest rate, and put that to the power of minus the time, because that'll discount at 0 periods, discount at 1 period or 2 periods. Remembering for the rate, we need absolute referencing so that all the formulas going down, we use that same rate. So the payment multiplied by the 1 plus the interest rate and then discounted for the amount of periods. So obviously the payment at time 0 is just 500. And if we copy that down, we will get each one, and then we might find the sum to get the total present value of these payments. So hopefully that's something familiar from earlier tutorials. We're going to see how to use it using the present value function. So this returns the present value of an amount of payments. It assumes that the payments are periodic, so every year or every month, and we've got constant payments. So you can see we've got $500 each year, and they're all 1 year apart at the same interest rate. So we can use the present value function. So it starts from time 1 or the end of the first period by default, but we can set it to start at the start of the first period using this type at the end. So you can change between in arrears or in advance. So we'll start by going equals present value and opening bracket. So first is the rate. So we'll input our rate. Then N per is the number of periods. So you can see we have 10 periods here. Our payment is the amount of the regular payment, and we enter it as a negative because the present value will return the opposite sign as the payment amount. So we put in minus 500 there. Future value is optional if there's an additional payment at the end of the period which is different to the regular one, which you might use in, say, a bond valuation or something later down the track. But for now, we're just looking at a single stream of payments. But if there was an additional future value, you could put it in here, but I'm going to leave it blank. And then for type, because this stream of payments is in advance, because our first payment is at time 0, I'm going to put a 1 in. If it was in arrears, you'd put a 0 in. So you can close bracket and enter, and you can see that these two are giving the same. So if we were told this information without the actual spreadsheet, we wouldn't have to enter all these values in. We can just say that we have an interest rate of 5% for 10 periods, $500 per period, and in advance. And it can finish up like that. So that's the present value function. Next, we have the net present value function. So again, it returns the present values. It assumes periodic payments, so once per year, but they do not have to be constant, like they did for using the present value function where we just had payments of 500. So that means we put in all the values individually, and it starts from time 1. So any payment at time 0 needs to be added separately. So I'll show you what I mean by that. So if you go equals net present value, so again, it asks for you for the interest rate that we're using. So I'm going to put it in as G4. Then putting in all the values starting from time 1. So our payment at time 1 will be the first one, and we include them all. That's because whatever the first value that it receives as a value is put in will be discounted by 1 period. So we can't include anything at time 0. But that's all we need to put in for this function. But then we're going to add separately that first payment, because obviously the present value of a payment today is just the amount of the payment. So we're going to add that on separately, whereas the net present value function discounts all of these appropriately, assuming it's from time 1, 2, 3, etc. So we can enter, we can see it gives us the same answer. But where we would use the NPV function over the PV function is when we have irregular payments, but they're still periodic. So once per year, once per month. So you can see we've got 500s, 400s. We have got a year where there's none. And so again, using the same sum formula, we can see this. And we're going to check that we get the same answer using the net present value function. So again, equals NPV. We can put in the rate. And we can put in all the values, remembering to start from time 1. So we still include time 8 being 0, even though there's nothing there, just to show that time 8 is 0. Close off the bracket and add on our payment at time 0. And you can see we're getting the same answer as if we summed them, the present values, using the formula as before. So the net present value function, you can have any types of payments. You just need the list of them in order, and you can do it in one function rather than having to find each contribution individually and summing them. Now the final function is XNPV. So this returns the present value, and it can be used for any timing of payments of any amount. So it's probably the most diverse version of this function. But what this does need is a range of dates and the payments at those dates, as opposed to, I guess, just times or their order each year. So with dates, it's harder to use the present value going like this, doing them individually, discounting each cash flow. You need to figure out how far away they are, and it's a bit more difficult in Excel. But using XNPV is a really nice way to do it. So this would be used if you know what payments need to be made at certain dates. You can just put in the dates. So you can see my first payment is on the 1st of January this year. And we've got payments at random dates. So nothing kind of periodic about them all the way until mid 2022. So what we need is the rate, so the interest rate again. Then for the values, we want to start from time 0 this time. So whatever date we want the valuation done at. So we're going to get the present value as at the 1st of January if I pull in all these values. And we can pull in the dates of all these payments as well. And it'll simply find the present value of all of these, assuming an annual interest rate of 5%, discounting all these separate values. So this one is, I guess, quite different in its application, but it can be used when you have a set amount of payments of an amount that you know in advance and the dates that they're due on. This can be a really easy way, rather than, I guess, calculating the time to each payment, which you might have to do using some of these other methods. So as a quick recap, the present value function, so PV, can be used as a quick shorthand if we have regular payments at regular intervals. So the kind of questions where we're looking at, you know, a payment of $500 every year for 10 years, it can solve that really quickly. The net present value function expands on that and allows you to use payments that are of different amounts, but it still requires it to be done each year or each month or each decade, whatever kind of time period you're working with. And then broader again is XNPV, where if you have a set of dates that payments are due and the amount of those payments, you can enter them as well as the interest rate to get the present value of those stream of payments. I'm hoping this video has been useful in introducing some of these. If you have any questions, feel free to post them on iLearn or send me an email. I'm happy to go through them in more detail if you have any questions.